Hi everyone, welcome to this webinar. Today we're going to introduce BTS technology and focus in particular on our wearable technology and on their functionality. So I think we can start. So as mentioned, we'll briefly go through all BTS technology and we'll explore the different wearable solutions. And at the end, we'll leave some space for some Q&A. So feel free to ask any question you have. So in the picture, you can see all our technology, but the focus here goes in the fact that what characterizes really the technology is that we produce them all. Hence, we are able to integrate all of them in the same software, which of course make it easier for the user. All the different technologies can be bought all at once to build a complete lab, but they can even be bought separately, so they can work both altogether, integrated in a single system, but also as standalone systems, according, of course, on the user's need. Here are all our products. So we have in our portfolio infrared cameras, force plates, EMG probes, video cameras, and inertia sensors. The native digital synchronization of the cameras, electromyograph, and sensorized floor, so the force plates, is guaranteed by being the only company that produces the technology, all the technology in particular. So this allows for instant-by-instant measurements of how the subjects move their joints, for example, how uses their muscles or distribute the forces on the support surfaces, so the force plates, during all phases of the movement. And information coming from all the technology can be acquired with one single acquisition. And at the end of the examination, the system automatically creates a detailed report in which the results are shown in a graphical representation, which is very easy to read. Here, just some pictures of the software on the left and some graphs that can be found in the report on the right, just to give you an idea of the software that includes all the technology and the type of reports that can be obtained. However, among all BTS portfolio today, we are going to focus on the wearable solution. So meaning that we'll focus on the system that uses the EMG probes and the inertia sensor. So the first system that we talk about today is the Baiobit system. The Baiobit system uses an IMU, so an inertia sensor, for a quick and non-invasive assessment of the patient's movement. The inertia sensor used by this system is called G-sensor or Baiobit sensor. And the solution is very practical, is easy, and supports the therapist in the assessment of motor functions, also performing some therapeutic exercises. The system, as you can see, is very small. The hardware, so the Baiobit sensor is very small, and the system has a dedicated software. The interface is very user-friendly and tests are very quick and easy. Baiobit is suitable for many applications depending on the patient's need. That's because integrated in the software, there are many tests available, such as, for example, the joint mobility test, the balance, gait, jumps, and the free test. For example, joint mobility is suitable to evaluate the range of motion of the trunk, shoulder, or cervical spine. The balance can be suitable to assess the postural oscillation and also evaluate the risk of falling. The gait is suitable to assess, for example, the gait quality, the symmetry during the walking, and even the motion of the pelvis during the gait analysis, of course. The jump instead evaluate forces, velocities, acceleration, and power while performing some vertical jumps. Baiobit also provides an exercise section, where it is possible to perform some biofeedback exercises whose main goal is basically to involve the patient and stimulate the patient, improving their proprioception. So the exercises available mainly focus on the joint mobility and the balance, and it provide audio and video feedback that helps the patient a lot in their exercise execution. Also, another functionality of the software is to assign some home exercises. And the main idea here is to do these exercises without a sensor, so assign some home exercises so that the therapeutic journey can continue even at home. And there are more than 80 exercises in the library, but you can customize the library and upload even your own exercises. So this was, let's say, the first technology. Then we walk into another one, which is the Freeemg system. The Freeemg system uses the wireless EMGs, so electromyograph probes, that allow a non-invasive evaluation of the activation status of the muscle chains. It provides information about duration and amplitude of the muscle activation, allowing also the monitoring of the activity of the tested muscles. Here's some specification of the system. So the wireless surface electromyographs measure the muscular activity during a dynamic movement, meaning that the person can move during the acquisition and the test. So it doesn't have to stay, still for the execution of the movement. And an EMG acquisition allows to identify the on-off activity state of a muscle. And this assessment is fundamental to evaluate the patient's state of health, also to be able to intervene with some personalized treatment pathways according, of course, on the specific issues detected thanks to the technology. Here are just some images of the EMG signal, which in this case was obtained while a person was walking, a patient was walking. This is just an example, but to give you an idea of what kind of information and graphs can be achieved using the Freeemg system. So from an acquisition, it is possible to understand if the muscle contracts and even to quantify the amplitude of this contraction. The system, so in this case, can be used to visualize also the real-time on-off state of the muscle. So if the muscle actually contracts or if it's relaxed, since the visualization of the EMG signal is in real time while starting an acquisition. So it can also be used for a sort of biofeedback test. Although, if the goal of the therapist, let's say, is to know if the muscle is active when it should be, and also if it is activating or deactivating properly, then it's fundamental to have a way to identify some sort of time events that characterize the movement in which the muscle are involved. So this need leads to the introduction of our last technology that we're going to see today, which is the Freelab system. The Freelab system is the integration of the technology that we just seen. So the Freeemg electromyographic system and the inertial sensor, so the G sensor. This integrated solution allows to perform a quick, accurate, and effective evaluation of the patient or the athlete. In fact, thanks to the integration of the inertial sensor inside the system, it is possible to carry out the analysis of specific movement, being able to determine the timing of activation of the tested muscles. So the system, the Freelab system in this case, allows to obtain a global assessment and formulate a functional diagnosis, identify any movement dysfunctions that can be residual or even potential, and investigate any kind of compensation strategies that can be can be there in the patient. So as mentioned before, the system includes the Freeemg system for the superficial electromyographic evaluation and the inertial sensor for the kinematic information about the movement. So this basically allows to visualize the behavior of a muscle during the performed functional movement. Just to give some technical specification, so some pros of the system that can be useful. So the device is wearable and it is totally wireless. It has also an onboard memory. So in case, for example, the connection is lost during the acquisition, data stays internally, so stays in the memory and are downloaded at the end of the acquisition. So when you press stop. The probes have 6 hours of autonomy, and thanks to the functional protocols that are integrated in the software, it is possible to perform some functional tests and have at the end a final report. The functional protocols can be used in many application fields, such as, for example, neuromuscular assessment, injury prevention, gait and posture, joint mobility, return to play, and functional training. And in the next slide, we'll go through some examples, some practical examples of this application, explaining, of course, also the respective benefits in the usage of this technology and of the specific protocols. So let's start with the gait analysis. So in this case, the gait analysis test allows to measure some temporal parameters, spatial temporal parameters in particular, left and right symmetry, muscle coordination, of course, because there's the integration between the kinematic system and the EMG system. This basically would allow to integrate the clinical experience with quantitative and objective data to optimize the treatment planning. And in case of a pre-post treatment evaluation, it would highlight and quantify the benefits of the treatment because you would have some objective data to actually see if there's any benefits in the treatment. Another usage example of the system can be the evaluation of the joint mobility. So, for example, in this case, we've shown the shoulder test, but the same test can be also performed for the cervical, for example, or even the trunk. The shoulder test, in this case, can assess tree movement, so flexion, extension, abduction, adduction, and rotation. And it would provide information about the neuromuscular assessment, the joint mobility, some any recovery improvement, and would also give information about the symmetry. So doing the exercise on the left, the test on the left and right side, it would give information also about the symmetry in the muscular activation and even the movement. As our last application example, the use of the system is also suitable in case of an injury. In fact, the system can be used to track the progress and even maximize the recovery of the athlete. In fact, the drop fall test is what is suitable in this case because it could be used to measure, for example, the muscular activity in the leg during the functional movement, which in this case is the drop fall test. The test, in fact, can objectify the effectiveness of the treatment or the training while providing also some motivation to the athlete toward the recovery. But, for example, the same test could also be used for injury prevention to evaluate the muscular activity and, in particular, the timing of the contraction of the tight muscle to see if they are, let's say, if they activate promptly to protect the knee joint during the fall. So that was briefly our technology, how can be used in some pretty much practical examples. Now the stage is yours. If you want to ask some question, if you have some, specific question, please feel free to ask. Thanks, Arsen, for the question. So the question is, which sport do I see athletes most use in the system? It depends on which system. If we talk about, for example, the Baiobit, the jump tests can be helpful in basically any sports. So jumps also are able to evaluate, the reactivity or the elasticity. So the power developed while doing the jumps. So basically, it can be used for training for any sports. In case of the drop hold protocol instead, so for the muscle activation, also in this case, so all the sports that use a lot of knees, that can be tennis, that can be basketball, even running. So knee joint is used or involved in basically any sports. So even for doing, for example, squat or lifts. So the question is, the answer is basically any sport. Okay. Yes, it can be used for children. Yes. Okay, so about the question, so it's Maximilian. How do you make sure that there are no or limited artifacts in the EMG, especially regarding force changes on the muscle or skin surface conductibility? In this case, to, let's say, reduce at minimum the artifacts, it's important to clean the skin before applying the electrodes. And we always recommend to follow some specific guidelines that, if you don't have, we can send by email for the correct positioning of the electrodes to, let's say, reduce at minimum the errors in the positioning and also in the surface conductibility. Okay, someone asked if there's Peter is asking if there are some differences between the old G-Walk and the new software that I've just presented today. So yes, the main differences are in the protocol that are available in this new software, which are basically regarding the range of motion tests. So the cervical, the shoulder, and the trunk. And also in the new software, there's the availability of performing the exercises with the biofeedback. David is asking if, let's say, how many inertia sensor can be used in the system. Only one at a time, because it's a Bluetooth device, so only one system can be connected at a time. And of course, you need to move it depending on the test that you want to do. So for the walking test, you place it on your pelvis. For the shoulder, you place it on your arm. For the cervical, you place it on your head, of course. Okay. Which tool can be useful meanwhile the sport activity like running? So this is Johan. In this case, you can use the EMG, EMG probes and the Freelab system in particular. And we have a run protocol, was not presented today, but we have a run protocol that can be used. It measures mainly the spatiotemporal parameters, so the walk while running, on a treadmill, and also evaluates how good and how symmetrical is the activation of the muscle inside a running cycle. And the same protocol is also valid for the cycling. So someone was, I don't remember who, but someone was asking also if it can be used for bicycles. So yes, you can use it in indoor cycling, and you can also measure the activity of the muscle while pedaling. So you place basically the sensor on the pedal of your bike, and you're able to evaluate the coordination, the muscle coordination during the bicycle exercises. I think I've answered to most of the question, but to all of them, all the one I haven't answered yet, we will make sure that we reach you by email, and we answer by email. One second, I'm just reading the question. Okay, so Riza, I hope the name is correct, is asking what types of clinical use can it be established by the software. So I don't know which software do you refer, but if you're talking about the Baiobit, it can be used to perform some gait analysis in particular. It can be used in clinical labs, also for physiotherapists. The same answer actually apply also to the Freeemg or Freelab system. It's especially for the range of motion, the joint mobility, it is used to evaluate a lot the mobility of the joints. And there's also the possibility to obtain at the same time the muscular activation inside the movement. So that could be useful in that case. And it is very used to evaluate gait. A lot of physiotherapists use it for gait analysis. It can be used for elderly or even children. So it is very versatile as system, both of them actually. Okay, so for more technical question or question about cost and about system in particular, we'll answer by email, and our commercial will reach you directly about this question. One last thing before I leave you. I wanna just introduce the next webinar that we're having in 1st of October. It will be more of a training, especially about Baiobit. And also, I wanted to share with you our upcoming events. So we'll be at Physio Expo in Madrid and Sinfer and Siamok in Italy in October. Thank you, everyone, once again. Bye-bye.